Hello, good morning. We are going to start the presentation of the Windext project. Our project is supported by the European Commission through the Erasmus Plus program and the Alliance section of the Erasmus Plus program. Well, the goal of this meeting is to present the main findings, the main outcomes of the project, and also to disseminate those outcomes, especially the Moodle platform, to promote the use of the contents and the digital tools of the Moodle platform. The total duration of this presentation is going to be 3 hours, from 10 to 1 to 13. There is an option to present, to make some queries and some questions in the platform, because now all of you are muted. So, but you can send questions, written questions in the question part of the platform of this webinar. The webinar, there's a site here called Preguntas in Spanish and queries in English, and then you can write what you can send any question. I'm going to make an introduction. My name is Alberto Ceña. I'm working for the Internet Association, AEE, and I've been with Vicky, Victoria Campos is beside me. We have coordinated all the project, all the technical, mainly the technical issues, because the administrative and the financial issues are being coordinated by SGS. After me, there is a presentation of the UCI about the Moodle platform. As I mentioned at the beginning of this webinar, our intention is to promote the use of the Moodle. So now the access is going to be free. You can see the content. You can see also you can download the digital tools. And as far as this has been a project supported by public money, we hope there is a public diffusion of the results, dissemination of the results, and to be used extensively in Europe and also in other countries. All the texts are in English. Probably in the near future, we are going to try also to translate into other languages, because the goal of this project, or the audience, or the target audience, are mainly the vocational centers, because we are oriented for vocational training. The second part after me and UCI, it will be all the presentation from to present the mainly general part of the Windext. Is the section 1 is going to be carried out by Delft, the University of Delft. I think Simon and Donatella are going to present the main results of this section. After this section is going to be the Castilla-La Mancha University. They are going to concentrate in the section 2 about maintenance, handbook, and virtual tools. So we have introduced in this project different virtual tools. One is the most common is the use of goggles, of glasses with virtual reality. There are 2 parts. One is SimulWin. It's an extension of the project, the software we developed in a previous project, SimulWin. Now there is also WebSim. It has been specifically developed in this project. The section 5 is going to be presented by Jaume Reynoso about life extension, reporting on health and safety. Besides the use of virtual reality, we are also extensively use H5P instrument or software developed by MIT, and this is quite flexible to introduce images and text, and also to be used in the part of the maintenance and also in the life extension, the section 3. Later, David Gonzalez from Tecnor is going to present the WebSim, how to download the use of the virtual reality. Simulwin is not going to be presented, but you can find it also in the Moodle platform, as well as the CADWEX. So there are in total three virtual reality or simulators. Well, there are different simulators because in the section 1 there are also simulators. But this specific simulator, there are two for virtual reality, Simulwin and WebSim, and CADWEX is a specific software for root causes in the case of gearboxes, and to follow in the case of a failure in the gearbox, which could be the root causes to produce that fault. At the beginning, there is a project conclusions. This is going to be done by Elena Tilko from SGS. And later we have the last 15 minutes is for questions and discussions. But as I mentioned, you can also launch your questions in the writing form in the question part of the webinar, GoToWebinar platform. I'm going to make just a short introduction, 10 minutes, because I have already spent 5. What is Windext? Windext was an initiative of the Spanish Wind Energy Association, and our intention when we launched the project, it was to cover one of the lack we have detected on training maintenance people. Is the difficulties to get access to two things. One are the typical maintenance handbooks of the turbines. Normally, the vocational centers are using partial documents, and in many cases not updated, and also the difficulties to get access to the nacelle. For this reason, we combine in Windext two things. One thing was the contents, the PDFs, and at the same time the virtual reality to. It's not the same, of course. It's better to go up hours to the tower to get access to the platform. But with virtual reality, you can have a really good impression what are going to working conditions when you start to work in the sector. Behind this idea, it was also another important issue is the lack of people. So now with the ecological transition, not only in Spain, also in Europe and in many countries, there are many projects are now being constructed, or are going to be constructed in the near future. But there is a lack of people to maintain those turbines, those wind farms, and then reinforcing the use of the instruments I mentioned before, we can accelerate the integration of people in the sector to cover this lack of specialized worker. Another important goal of the project, it was to combine the experience of the university and the vocational centers. Normally, the activities of both are quite separated. There are no a good integration between universities and vocational centers. And our idea when we started with the project is to create some links between the universities and the vocational centers, because finally the target audience are maintenance people are going to be in the market. The consortium, it was mainly European institutions or companies. It was 8.2 from France, RC Consultants from Germany, DP2I from 8.2 from Germany, sorry, RC Consultant from Germany, DP2I from France, Tecnor from Spain, Inestec Portugal, Delft Holland, Castilla-La Mancha Spain, and Cyprus University from Cyprus. UTEC is also the Technical University of Uruguay, and also we have the intention to spread the results of the project in Latin American countries where there are many European maintenance companies very active there, and so the idea was also to extend the results of the Windext to Latin America. And finally, SGS, Spanish multinational company, but in our case is the Spanish branch who have been involved in the project. The next slide. Well, those are the main outputs of the project. We are not going to enter in detail because it's going to be presented later. But there are the three main groups are WEXSIM, the virtual reality simulator. WEXLab are the simulators developed by the Delft University for especially for explaining how is the operation and the control of the wind turbine. And WESWIR are the instrument developed by Castilla-La Mancha University based in H5P, also especially for handbooks for preventive, predictive, and corrective maintenance. Once you enter into Moodle, you will see something like this. You can get access to the different sections. As I said before, the WESWIR, WEXSIM, and WESLab are integrated, so you don't see, except WEXSIM is the virtual reality. WESWIR and WESLab is some brands we have created, but the simulators are in section 1, in section 2, and section 3 and 4 are the simulators you are going to use when you download. And in some cases you need to use goggles. They are not expensive now. For 300 euros you can buy goggles. And once you download the software, you can the turbine, you can enter into the different simulators, and we have developed different maintenance practices. And the first thing I will recommend to enter into the tour. In the tour, 360 degrees tour. Thanks to the tour, you get familiar how are going to be the space, the lack of space, of room for working in the up tower in the wind turbine. So this is the scheme. As I said before, WEXSIM, WISIMULWIN are specific simulator. CADWEX can be downloaded in a computer, but WEXSIM and SimulWin, then you need goggles to be used. The next, please. So only a few words about the importance of maintenance. Everybody is familiar with maintenance, but only a few words. As I said before, our intention was to cope a lack of people in the sector, to make more professional work for maintenance companies, and the final goal intention, it was to improve the quality of maintenance. Normally, all the wind farms in the world are going to be in operation for more than 30 years, and then they request a quality maintenance work. So for this reason, I'm going to just to give some ideas here. For this reason, we have launched this project. In general, when we are doing a project, we have introduced in Windext some ideas. I think are quite original, because we have also introduced some model of contracts. It's just to check if you are going to work in the sector. It's quite useful to understand which kind of arrangements has the maintenance companies with the owner of the plant, and to see also which are the KPIs are going to be requested when the maintenance work is being done. So another thing I want to remark is we are not only concentrated on onshore wind farms, we are also making some part of the Windext also for offshore. It's true that the main difference between onshore and offshore is to get access to the turbine. We are not entering into this part because well, it will cost more money for the development, to movement of people on ships, and to go to the turbine from the ship to the turbine. So probably in the future we're going to do something on that side, but the rest of work is similar. So once you enter into the turbine, it's the same to maintain an onshore turbine and an offshore turbine. So here there are some ideas. So the life cycle of a project we need to consider from the development, construction, operation, and decommissioning is important when we are constructing the project, to take into consideration that the project is going to be maintained later on, and then there's the area of work, especially for corrective maintenance, to be prepared for maintenance working. Next slide. Well, there's also some in the asset management, there's also financial management. We have no entry into detail in the financial management, except of the contracting arrangements I mentioned. But keep in mind that now when you work into the sector, it's important to consider that you are selling electricity, receiving an income, and this should follow the cash flow, the cash flow you are expecting from the project. Next one. Which are the main technical tasks of the project? So first are the procurement. For instance, one thing we have learned recently in the maintenance of the wind turbine, the spare components more requested in the market are the power electronics. It's curious now because in the past, power electronics more or less a commodity. But now, considering the difficulties of supplying power electronics, is becoming an issue and also important to have in the stock of power electronics for maintaining turbines. Well, here also there are some. We're going to share with you this presentation. I'm going to leave my colleagues to present the platform. So probably we can launch. I have already used my 50 minutes. No.
Yes.
We can now go to UCI, to Marios Kyprianou and Konstantinos Xenofontos to present the Windext model. And here there are just general ideas why we have developed Windext, but I think it was clear that we are developed the Windext project because there's really a request from the market for maintenance people, and now we have progressively more and more projects in the world to be properly maintained with quality and professionality. So now, please, UCI people, are you prepared?
Yeah, hello. Do you see my screen?
Yeah, we see your screen.
The Windext platform?
Yes, we see the model. Yes.
Okay, thank you. So my name is Marios Kyprianou. I'm from Cyprus and I'm working at University of Cyprus at Software Engineering and Internet Technologies Lab as a researcher at Software Engineering. Today I will present you how to use the Windext platform. This is our platform homepage, and the link of our platform is windex.cs.ucy.ac.cy-moodle. You need to have an account to have access to the platform. If you don't have an account, you need to create one, and let's create a new account. So you need to complete some fields, a username, and the password. Please pay attention that the password must have at least 8 characters, 1 digit, 1 lowercase letter, 1 uppercase letter, and 1 non-alphanumeric character. So complete my email address. My name. And when you complete the fields, click on create my new account. So you see that you take an email and now go to your email, and you can see that we take an automated reply from Windext course, from account confirmation. You need to click on this link. And you can see a message, thanks Marios Kyprianou, your registration has been confirmed. And when you click on the continue, you have access to the platform. As you can see at the top of the platform, we have some syllabus about the Windext and some user guidelines. And next, we have the 4 sections of Windext course. To have access to these sections, you need to enroll yourself in the section. So let's click to the first section, access button, and then enrollment button. So now you have access to the first section of Windext platform, the introductory to wind turbine technology. The section has some basic structure, an introduction with a video and some learning outcomes, and some modules with read section and applied section. And at the bottom of the section, at the end, we have some quizzes for the users. If you want to go to another section, you need to click here. We are in the home page of our platform. Let's have access to digital tools. The same procedure. We need to click to access, to enrollment button, and now we have access to the section for digital tools. The structure is the same to all of the sections. And that's all from my side. I don't know if we have some questions.
Marius, are you connected?
Yeah.
Okay. Because we can hear you. I don't know.
Are you finished?
Yeah, you didn't hear anything?
No, I could hear you.
No, we heard you, Marios. We were just checking. We were just checking that. I think you were pausing questions.
Yes, I'm finished.
Okay.
Okay.
Thank you.
Thank you, Marius. Now it's time for Simon Watson and Donatella Zapata from Derby University.
Thanks very much. Alberto, I'm just going to check that you can see the right thing. Let's see. Hopefully you can see the PowerPoint slides. Okay, so you can see them. Good, thanks a lot. Okay, so my name's Simon Watson. I'm Professor of Wind Energy Systems. I'm also the head of the Wind Energy section and the director of the TU Delft Wind Energy Institute at TU Delft, obviously. So we, just by way of introducing the section itself, we are a section of 50 or 60 people, if you include all our researchers. And the research that we do is quite a broad base of research activities related to wind energy, from looking at the aerodynamics of the turbines, to the systems design, to the turbine layout, looking at the aerodynamic interactions of the turbines, the wake losses, the wind conditions they're operating in, the loads on the turbines, and also we look at things like airborne wind energy, although that's obviously less relevant to this particular webinar. We're also part of the TU Delft Wind Energy Institute, TU Wind, because within the university itself, there's a large body of research going on in wind energy in other areas such as wind turbine control, the connection to the network, the foundation design, and areas such as wind meteorology. So there's a broad research base at the university that we've drawn on in order to develop some of the tools, some of the information, some of the background notes and teaching information for this particular course that we've developed as part of the Windext project. So as you saw a second ago, the Moodle platform is divided into different sections. The first section is Introduction to Wind Turbine Technology. And we have produced for that platform some written material, which I will kind of go through in relatively brief detail today, which provides both those people who are new to the wind industry, technicians perhaps who want a bit of a background information on some of the underlying theory and some of the technical information related to wind turbines, and also for students, because obviously one of our main areas of interest as a university is providing educational tools and information for our students. So that information is also aimed at them, as well as for people working in the industry, particularly people who are new to the industry and people who are interested in operations and maintenance. So we provided written material. So I'll talk through that in a little bit of detail. I'll talk about some software that we have developed. The software is still at a relatively kind of, it's relatively new and we're still polishing it, and we've still got a little bit of work to do on it, but I'm going to show you 4 pieces of software that we've created, which allow people to play around a little bit to see some of the important aspects of the design and the operation of a wind turbine. So we've created some software which is downloadable from the Moodle platform. I think a second ago the quizzes were mentioned by Cyprus, University of Cyprus, and we'll give you a quick overview of those, which are available so that students can get some feedback on what they've learned from the notes that have been provided on the Moodle platform and the software that they can run. Okay, so the written course material is divided into a number of different sections that we wanted to cover, 7 principal sections. So one is an overall introduction to the building blocks of a wind turbine, so that, as I said, those people who are new to wind energy get a feeling for, how a machine is screwed together and how it operates. And then we look into specifically the wind turbine rotor and how that is designed from an aerodynamic perspective to give people who are again new to this area an idea of the performance of a turbine and how it relates to some of the design parameters of the blades. Then there's a section we have looking at the loads on a turbine. So there's an appreciation there of the loads that result from the aerodynamics, the aerodynamic torque and thrust that's produced by the rotor, the implications that has for the design of the machine. And kind of following on to that, also looking at a modal analysis. So it's very important, the dynamic response of the wind turbine. So giving students and, as I said, new technicians some kind of a feeling for how you can look at the dynamic response of the machine and the things that you need to be aware of in wind turbine design. And then a section which looks at how a wind turbine is operated and controlled, so looking at the different phases of the operation of the wind turbine, again to give an appreciation of in the field how these things are operating. And then the kind of broader wind farm itself. So there's a section of notes looking at the layout of the wind farm, the electrical connections, and some of the criteria around that are required in terms of an optimal layout, looking at things like wakes, for example. And then finally, excuse me, finally we have a section which looks at reliability, failures, faults, and then there's a description of fault tree analysis, because the material developed in Windext is very much focused on looking at operations and maintenance, and a large part of that, of course, is how you deal with the issues around reliability, failures, faults. So there's a section on that, and as you'll see in a second, there's also an accompanying spreadsheet that's been developed to try and supplement the learning there. So the software, there are 4 software packages that we've developed. As I said, they're still being refined at the moment, but in a second I'll show some short demo videos showing how the software can be used. So the software products, the first one is looking at the overall kind of high-level system analysis, which relates the cost of the turbine to things like the size, rate of power, and the size of the rotor, and how those things lead to the capacity factor and the levelized cost of energy for the turbines at a very high level, just to give people appreciation for some of the basic design parameters. And then there's a software product which does a load analysis, so it looks at the loads that you get on the blades as they're in operation. And then similarly, another piece of software translates that into the dynamic response and carries out a modal analysis and gives students, scholars a bit of an appreciation for, if they change different parameters, how that's important, or how that impacts on the different resonances, the natural frequencies of the structure, of the blades and the tower, and how important they are in the whole design process. And then finally, a section looking at the operation and control, and looking at the potential impact of a fault. So, for example, a pitching problem. So these tools we've developed are based on using the MATLAB software and also OpenFast. Now, you don't have to have those software products themselves. We've created a version that you can install, so you can then use that without having to have the supporting software. We are thinking about making some of the code, the MATLAB code, available for people who want to develop it further, and the OpenFast code for people that want to develop that as well. But for the moment, we're just creating these downloadable, installable software packages that you can use, which, as I said, we're still refining at the moment. To support, as I said a second ago, to support the section on looking at reliability and faults, we've created a spreadsheet which gives an example of how you can look at the reliability of different components and how they then feed into the overall reliability of the turbine itself. And that can be obviously modified by someone. So it sets out an example of how you can create one of these fault trees, and you can play around with different parameters in the fault tree to see how it affects the overall reliability of the turbine. And then we have, as was mentioned a second ago, we've got some quizzes which have a set of questions to test the knowledge on the basis of the material, the notes that we created, and also the software that people can try out, which is based on different types of questions. So we've got multiple choice questions and multiple response. We have questions which require the person to actually do a calculation and provide a numerical answer when they get feedback on whether that's correct or not. We've also got drag and drop, so you need to identify various components, for example. And so I should go back a second. So the quizzes are available on the platform. And Donatella, are you going to go through quickly some of the examples of some of the questions from the quizzes here, or?
Yes, if you want, I can jump in.
Okay, shall I? I mean, I can just show on the screen here.
Yeah.
Oops, sorry.
Hello, good morning.
let me go back to that. Shall I? What's the easiest thing? Is it for me to?
Yeah, just leave it as it is. Okay, you want me to? Okay, leave it as it is. I can go through the slides.
Oh,
yes,
okay.
Essentially, the section here is divided in 7 modules, and then for each modules there is a set of questions where essentially you can practice your knowledge and your learning from the modules. And then the Moodle platform offers some flexibility in how to set up those questions. So there are different formats. And here there is an example, for example, from the first module. What do you know about wind turbine components? And then yes, some example on the left about multiple choices questions about why do we use the gearbox, or for example the type of foundations. So the learner goes through the questions, and then in some cases there is more than one right answer, so sometimes it can be tricky to find the questions that are their answers that are correct. But the good thing is the Moodle platform also allows to shuffle the questions. So every time the learner is going through the quizzes, essentially it doesn't go through the same order. And then same time, the numerical questions, and then we will see an example later, have some flexibility. So essentially the data that are in the question are always different. So essentially there is a way to practice in case the first attempt was not good. So on the right hand side here is an example of drag and drop. So essentially, again, learning a little bit more about the wind turbine components. So there are questions related to identify by dragging the names on the figure of the nacelle of the key components, and then on the bottom is about the gearbox. So there will be some learning about the different types of gearboxes, the different stages, and here is just a test to check whether the learner is aware about the different stages, planetary and parallel. In the next slide, yes, there is an example of another module where we look at the design of the wind turbine rotor, and this is an example of essentially other type of questions. On the top, drag and drop the text into text, so identify, complete the sentence in somehow. So the learner should drop the right words in the right order. And at the bottom is there are some examples of numerical. So I think there is a missing title. If you click again, Simon, probably you see the. So there's a multi-choice. There are multi-choices questions with calculated answers. So as I said before, here you see in the question there are some data regarding, for example, the diameter of the rotor or things like that, and then these numbers, like the 90-meter diameter of the rotor, will change every time the student is going through the quizzes. So it's not always going through the same questions if he repeats the quiz. And the next slide is about the final module, where we look at the reliability. So what essentially is important when we want to figure it out, what are the most critical components in a wind turbine, so that we can essentially do the maintenance. And here there are some examples of numerical answers, numerical questions where you have information about failure rates, and then you, for example, have to figure it out what is the mean time between failure, or anyway, all the information related to the failures of the turbine. On the right hand side, you can see an example of what I think Simon is going to show you later. So the spreadsheet is the fault tree analysis, and here the learner can practice a little bit with it. So there are some data at the bottom of the figure, and then using this fault tree analysis, which is given, the learner is asked to answer a question. So there is lots of variety in the type of questions, which is, I think, is a good way for learning and practicing what is in the modules. That's it for me, Simon. I don't know whether you want to show on the platform as well where the quizzes are, but I think they have already been shown before.
Yeah. I think we already saw those. So that's probably okay. So
Okay.
That's fine. Thanks, Donatella. So as Donatella says, there's a question here on the right-hand side which relates to looking at effectively how the reliability of different components cascades to the overall variety here of the rotor. So there's a spreadsheet which we've created. We just changed the application that I'm sharing so you can see that. Okay, we can see a spreadsheet, hopefully.
Yes.
Okay, good. So you can see here what we've done is we've created a spreadsheet which allows you to calculate the overall wind turbine availability here. So you can see this is the turbine availability based on the availability of the different subcomponents. And you can have different layers, obviously, of course, in this, because certain components grouped together and their reliability affects other larger parts of a subassembly of which they are part. So we're looking at different mechanisms here, failure mechanisms, for example here. So looking at where you've got information about the failure rate and the mean time to repair, you can calculate for different failure mechanisms here. You can then use that information to calculate the overall availability at different levels, cascading all the way up to the top level, which is at the turbine itself, of course. So you can see there are some example figures that are being given here based on sort of data that's generally available, but of course you can play around with these figures here. So you can see we've got some information about this is looking at gear teeth. So poor design of gear teeth here, and there's some figures here in terms of availability here that's been calculated based on the failure rate and the mean time to repair. So there's examples here of where we've got 0.01 as the failure rate per year, and the mean time to repair is being 150 hours. But you can change that information there. So we just change that to something like 250 hours and see what impact that has. So that impacts the availability figure here, but it also cascades up and affects this figure here and here, and then finally will have some impact at the top level as well, maybe quite small. But what it does allow is someone to play around with the numbers and get a feeling for the impact that might have on the overall availability of the system. And if they want to, they can add things to this as well. This is just an example that's being given here. So just to give students an idea of how you put one of these things together and how the formulae are created. So you can click on the different boxes and you can see how the formulae are created. And then if you want to, as I said, you can add in more components or more failure mechanisms, or even different layers as well, if you've got other things that feed in at a lower level. So it's just to give an idea of how you calculate an overall reliability or availability here on the basis of a fault tree. So that's the spreadsheet that we've created that people can play with. The final thing I wanted to talk about was the software that we created, which allows students to get a feeling for sort of the overall design of the turbine, loads, modal analysis, and also operations and control. So what I'll do is I will share some videos that we've created. So rather than try to run the software live, which almost certainly won't work properly because these things never work live, what we've done is we've created some videos, and I'm just going to play, whether I'll have time for all of them I don't know, but play them to give you a feeling for what they look like. So first of all, this is looking at the overall system design based on the rated power, the size of and the size of the rotor. So hopefully you can.
This video shows how to use this application to analyze the wind turbine at the system level. By using this application, you can calculate the rated wind speed, capacity factor, levelized cost of energy, CapEx and OpEx. You can plot the power curve. you can see the effects of the blade length on the levelized cost of energy and the capacity factor. To do that, you should first choose the location of the turbine, which can be offshore or onshore. Then you should enter the rated power, cut-in wind speed, cut-out wind speed, blade length, and tower height. As an example, I enter 7 megawatts for rated power, 4 meters per second for cut-in wind speed, 26 meters per second for cut-out wind speed, 80 meters for blade length, and 110 meters for tower height. By pressing this button, the application calculates the rated wind speed, levelized cost of energy, CapEx, and OpEx. It also plots the power curve. The blade length affects the levelized cost of energy. So choosing the optimum blade length is an essential factor in designing wind turbines at the system level. By pressing this button, the application plots the blade length versus the capacity factor and levelized cost of energy. As we can see, for the case of 7 megawatts rated power, the optimum blade length is around 90 meters. If I enter this value in the previous section, the code calculates the optimum value for rated wind speed, levelized cost of energy, CapEx, and OpEx. It also plots the optimum power curve.
Okay, so this is, as I said, a kind of a relatively new version of software that we've created. So there's still some refinement going on. There's still some error trapping I think we probably need to play around to check on here. At the moment, I don't think there's anything to stop you making the tower height a bit too high compared with the blade length. But this is a kind of our first software that we're releasing, which allows, in this particular case, someone to get an idea of, you know, as you play around with blade length, what impact it has on the costs. At the moment, the underlying cost information is fixed, but we're hoping to modify this to allow the user to change the information so they can play around with it as costs become, change over time. So that's the first piece of software. The second one we've got relates to looking at the load. So we'll have a quick look at that one.
This video shows how to use this application to calculate the load on...
1 second, I think that's not showing. Let's just try again. Let's try again.
This video shows how to use this application to calculate the load on the blade of 5 megawatts wind turbine. By using this application, you can calculate the aerodynamic load on the blade. You can calculate the total load on the blade of an operational wind turbine. To calculate the aerodynamic load, you should enter the wind speed, pitch angle, and yaw angle. As an example, I enter 7 meters per second for wind speed, 5 degrees for pitch angle, and 10 degrees for yaw angle. By pressing this button, the application calculates the aerodynamic load and plots the load versus the rotational speed. You can select the load type from the drop-down list and see its plot. To calculate the total load on the blade of an operational wind turbine, you should enter the simulation time, average wind speed at the hub, and turbulent model of wind from the drop-down list. The turbulent model can be a normal turbulent or extreme turbulent model. By pressing this button, you can see the plot of wind speed versus the operation time. To calculate the total load on the blade, you should press this button. It may take some minutes to see the message. After seeing the message, select the load type from the drop-down list to see its plot. It should be noted that in an operational wind turbine, the pitch angle, yaw angle, and rotational speed are chosen by the control system. This is the subject of Module 5, and an operational analysis application has been developed to simulate the control system behavior.
If I just scroll on here, because It takes a second or two to. Okay, so you can see that once it's run in this case, it allows you to look at some of the different load parameters on the turbine, so on the blades in this case, so you can get a feeling for how it's impacted by a particular type of wind field. So if you play around with the different turbulent wind fields, you see a slightly different response here. So that's the loads, and then we've got one which looks at the modal analysis. So let's just see, hopefully we can get that one to run.
This video shows how to use this application to perform the modal analysis of the 5 megawatts wind turbine. By using this application, you can calculate the blade and tower natural frequencies. You can plot the Campbell diagram. To do that, you should first choose the blade or the tower for the analysis. Then you should enter the blade length or tower height, hub radius, and nacelle weight. By pressing this button, the code calculates the natural frequencies of the blade or tower. It takes some minutes to see the message. The results are written on the text file named bmode.out. It is in your C drive in the modal analysis folder. To do the modal analysis, open this text file and enter the first and third natural frequency of the blade or tower in this box. Select the blade or tower mode from the drop-down list to see its Campbell diagram. In the Campbell diagram, 2 dot lines show the operational region of the wind turbine. If the intersection of 1P and 3P load frequencies with first and third blade or tower frequencies lies in this region, your turbine design doesn't satisfy the modal analysis requirement. So the wind turbine should be redesigned to change the blade or tower's natural frequencies to meet the modal analysis requirements. For this example, the intersection of load frequencies with first out of the plane natural frequency of the blade lies outside the operational region. So the wind turbine design meets the modal analysis requirement.
Okay, so that one is to give people an appreciation of looking at the different frequencies and how they can impact the design, and how you can analyze that using a Campbell diagram. And then finally, just to show the final piece of software we've created, is to look at the operation.
This video shows how to use this application to perform the operational analysis of a 5 megawatts wind turbine. By using this application, you can see the CP lambda curve of a 5 megawatts wind turbine. You can see the operational performance of a 5 megawatts wind turbine with a healthy and faulty pitch system. To see the CP lambda curve, you should press this button. The application plots the power coefficient versus tip speed ratio for different pitch angles. To see the operational performance, you should first select the step wind model from the wind type drop-down list. By pressing this button, you can see the plot of wind versus the operation time. The wind increases in steps from a cut in to a cut out. For this case, the operation time has been fixed to 300 seconds. Then, you should select the normal operation from the turbine condition drop-down list. Then by pressing this button, the application calculates different operational parameters. It takes several minutes for the program to run the code. When the message "the code was successfully run" was appeared. You can select the operational parameters from the operational parameter drop-down list and see their plots. You can select torque or power and see how they change when the wind increases from the cut-in until the cut-out. You can also see the plots of pitch angle, in-plane, and out-of-plane tip deflection versus operation time.
If I scroll on a little bit, because that takes a few seconds. So we've got some examples here of different parameters you can look at normal operation. And then similarly, you can do another run where you've
If
got
one encounters a
faulty operation.
and it cannot pitch this blade, it takes several minutes again to see the message.
So I'll scroll through just so avoiding that bit there. So again, we can look at different parameters. This case, there's a fault with one of the pitching mechanisms of one of the blades, so you can look at how that impacts some of the deflections and some that you're seeing on the blades because of this pitching problem. At the moment, this software is just based on parameters from the NREL's 5 megawatt wind turbine. Again, with some development, we will allow people to use other different types of turbine parameters if they have them. So this is just the first pass of the software that can be used. Okay, so that's a bit of an overview of the teaching material and the software that we've created for this this module, which is Introduction to the Wind Turbine Components. Okay, I'll pass on next to, I think, Estefania, are you next?
Hello, good morning.
Yes,
Yes,
I'm next.
yeah. Before going to with the next speaker, there is we see that Virginia Godia, she raised her hand, so we are going to activate her microphone, so maybe she can ask. Virginia?
Good morning. Before we were talking about the quiz questions, and I would like to know once we are registered in the Windext page, how we can go to the quiz questions.
They should be just available on the, let me just go to the course. So you can see the course here.
At the bottom of the module, yeah.
You go to the bottom of this first section, then there are quizzes, and then you should, it might take a few seconds to open it. I think I noticed this before, but if you click on one of them and then wait a few seconds for it to load, there, it should come up. I don't know if you can see this now. I think I've already started one, so I think I probably need to continue it. So here you can see these are the questions. So there's an example question here. This is a multiple choice question.
Okay.
And you can come back to it later, and then I think you can at the end click to say you finished your attempt. I think I was halfway through an attempt here. You can click through the questions one by one, or I think you can choose them in what order you like, actually.
Okay.
So, yeah.
Then I can register my pupils in the class, and everyone can do this quiz.
Yes, you can enroll them in the Moodle. You have to do it by yourself with the new login, and you can create all the accounts that you need, and then they can go inside the Moodle, enroll to each section, and they can access to all those quiz. Yes.
Okay, and with the exercises, I have seen some exercises of virtual reality. For example, to change a fuse in the cell, we can do it in the computers, or these exercises are only for the classes.
We are going to explain that part. Then David is going to explain it about Wexim, but that experience that you are talking about is for doing with the goggles, just with the goggles. Then we have also SimulWind that you can do it with the computer, but Wexim, you need the Oculus Quest goggles. Yes, David is going to explain that part.
Okay, thank you very much.
Okay, Estefania, shall I hand on to you then?
Yeah, I think so. Vicky, can I?
Yes, you can present now. No, we see your screen already.
Okay. So I will start. Hello, everyone. My name is Stefania.
We can
Artigao.
see you, Stefania. We see your presentation.
But you can see my presentation?
Yes. But we don't see your camera. Yes, your presentation. Yes. Now we see you.
Okay, thank you. So yes, my name is Estefania Artigao, and I work at the University of Castilla-La Mancha, or UCLM. We have been working in this Windext project mainly on section 2, which is the section for maintenance. In this section, like my colleagues from University of Cyprus explained, is when you enter the Moodle, you can find it under section number 2, maintenance. And what I'm going to explain now is the content of the section. So basically, this section covers anything regarding operations and maintenance of wind turbines. We have divided this section in 6 modules, in different modules, which we'll see how they are organized. And this is what we can find. We will find an introduction to the types of maintenance. And as you know, there are 3 main types of maintenance, this being preventive, corrective, and predictive. Then we have made another module for offshore maintenance with highlighting the differences or stating what's different, which is mainly the foundations. We'll see. And finally, we have a module for asset management and contracts with some information. We will go through each section as follows. So this is how it looks within the Moodle platform. Now, at the beginning of the section, we have an explanation of the section, and then the 6 different modules that I mentioned, and finally, following the same structure that Simon showed, Simon and Donatella, we have the tests to test all the information that you have been learning in this section. And we added a final section called Broaden Your Knowledge, with some extra documents that these are available online, but we found them interesting for the readers or the students, so we put it there. So like I was saying at the beginning of the section, we have a video explaining briefly what I'm going to explain now and what you can find in the different modules of the section. We can also see the requirements to pass the section and the learning outcomes. About the requirements, we recommend that we perform section 2 after section 1. Because in section 1, like my colleagues just explained, you have an introduction to wind turbine, not only to wind turbine technology, but also to wind turbine components, and to get familiar with the terminology of the wind turbine. Then we explain here as well that for every module, normally you will have a read it part and the applied part, which I will explain. And so we recommend as well that you go first to the read it part and then to the applied part. So moving on, the first module, like I was saying, is an introduction to the different types of maintenance. So this is a very short document that introduces to wind energy around the world, in Europe, some figures, but obviously these figures get obsolete in every year. So, but just an introduction to get a feeling of wind energy, and then the different types of maintenance, and it explains how we divide it in these the 3 blocks that I mentioned. So preventive maintenance, corrective maintenance, and predictive maintenance. So basically, it's a brief summary of the whole section. Now, in my presentation, you can see that all the PDF documents, so all the written material, it appears twice with the log and without the log, and it also says hidden from students. This is because teachers like me, I'm enrolled as a teacher. I have access to the full PDF document, but when students register, so new people registering in the Moodle platform, will only be able to see the logged document, so that it's it's the same PDF, but it's just protected. So forget about this double naming for the PDF documents. So this is for module 1. Now, if we go to module 2, actually to the right of this, you can see the content that we have. But if we go to module 2, we will have first the Reddit section with some written material, and then that it's the Reddit section, and then you have the applied section. In the applied section, we have used, like Alberto Ceña explained at the beginning, we have developed what we call digital tools, which are based on H5P, and these are interactive tools to show the same information that you can find in the handbooks, but in a more interactive way, so that the student can interact with the content that the student is reading and learning. And this is to cut their attention a bit. So the preventive maintenance module is probably the core of this section of maintenance. And I'm gonna explain briefly what we can find for each of these parts. So first, about the handbook. This is the table of contents of the handbook. As you can see at a glance, is a very dense document, because obviously we have tried to include here all the procedures that we have to develop in a wind turbine, which are many. So we have here over 100 maintenance procedures. In this document, it's important to note that we have tried to develop a generic document. So we know that there are many different types of wind turbines with where the components can vary from electric to the different types of components that we can find, for example, in the geosystem or other systems, or hydraulic system. Anyways, we have tried to develop a generic document where we have tried to avoid the specificities of wind turbines, and we have tried to add as many procedures from different wind turbine manuals, so as many as possible. It's also important to note that for every procedure, we have added the health and safety part, because health and safety is a very important side in this sector, in operations and maintenance. And luckily, in the consortium, we have an expert in health and safety. And so we have added the procedures and the health and safety regarding that procedure. And also regarding the wind turbine breakdown or components breakdown, the taxonomy of the wind turbine, it's important to note that we have been consistent all across the section. So for example, in section 1, you can find the first part explaining the different components of the wind turbine, and we have been consistent all across the Moodle platform, like I was saying, to avoid confusion between the students. So this is for the handbook. This is just a PDF document, like I said, with all these procedures. Of course, the procedures are, each procedure has to be done at different time intervals. So it's also very important regarding preventive maintenance, the checklist. Again, we have tried to make a generic checklist where all the procedures have been summarized in a table. This checklist is about 7 or 8 pages long, and obviously is consistent with the handbook. And here we can find, like I was saying, the procedures and the times, the intervals where you have to develop each procedure. Of course, the names of the assemblies, the sub-assemblies, the components, and all the different procedures are consistent with the handbook. So this would be for the written material of the preventive maintenance part. And now we move on to the apply section. In the apply section, we can find 2 types of digital tools. And the first one, we call it a guided digital tool. And then we have another one that we call it a move around. Now, the guided digital tool is kind of presentation that is similar, reminds of a PowerPoint presentation, but like I was saying, the student can interact with this digital tool. Instead of just reading, as you would read a document that is page after page after page, here we have added the same information as in the handbook, but organized in sections. So in the handbook, the Winterby taxonomy that we defined was based on 10 different components, and this is what we have here. So to the left of the image, you can see the list of main assemblies. Then if you click on any of each of the assemblies, you see the image that appears to the right of the screen. And it asks, what task do you want to perform in the drivetrain, which is, for example, the one that we selected. So, and then you have a list of the procedures that you can perform in the drivetrain. In that list, the first item, you always find a video on where is that component based on the wind turbine. That's why you can read accessing the drivetrain. So there you can see a video of moving into the wind turbine and then going all up the way to the tower, all up to the nacelle, and then where you can find the drivetrain. And this video, it's a very short video, is performed for every of the components, for all of the components, so that the student can get more familiar with where the component is based. Because probably for us here in this webinar, we know where the gearbox is, or we know where the UO system is, but maybe the students, when they start looking at this, have no idea of what is the drivetrain or where is the hydraulic system located. So the first item is always a video to show the location of the component. And then you have the list of the procedures that you have to do for maintenance. So for example, when we click on one of the procedures, then again, on one of the components, or for example, here, the first one was connection of the rotor shaft hub. Then if you click there, you can find the different steps that you need to follow to perform maintenance, the maintenance procedure that is called connection of the rotor shaft. And here it's organized with icons, and you always have, you can always see the picture of in a real wind turbine of what the drivetrain looks like, or the generator, or the UO system. There's always a picture behind. So in theory, this should attract the attention of the student and keep him or her engaged. Now, so this is for the guided digital tool. Oh, when you finish reading the different steps for this procedure, then you are asked if you want to perform another task in the same element, or if you want to select another element, or if you want to finish. So if you select another element, you can go back to the main menu and change assembly, or you can move in the different elements, or go back to the main menu, or just finish. So this is for the digital tool. And now the move around digital tool. So what we have done is, again, we have added the same information, so all the procedures that you can find in the wind turbine, but we have added now to this move around tool. This move around tool is based on, again, on H5P, and it was developed by another consortium member. And this based on these 360 images of a real wind turbine, so you can move around the wind turbine by clicking at the arrows. You can enter the wind turbine, go up the tower, move around the nacelle. You can even go outside, and you have a very nice view of the wind farm. Anyways, here, like I said, the wind turbine was divided in 10 components. So in each of the components, we have added these labels where you can find the different tasks, maintenance tasks or maintenance procedures that need to be done in each of the components. So the student can, after having read the manual or after having gone through the guided digital tool and all the steps, he can practice moving around the wind turbine and checking the tasks that need to be done in the components. But now is the student who can take himself or herself to each specific component. It's important to note that we can always find two labels. One is for the tasks, and the other one that always reads attention. You can see it's regarding, like I said, the health and safety procedures for each of the requirements for each of these to perform the different tasks. Okay. So that was for preventive maintenance. Then that's probably the biggest module in this section. Then if we move on to the next one is corrective maintenance. Now for corrective maintenance, again, we have first the read-it part where we can find the manuals or handbooks, which is written material in PDF. And then in this case, we only developed the guided digital tool. And the reason is that corrective maintenance is different to preventive. So preventive maintenance, we have these scheduled tasks that we need to perform every time interval, but corrective maintenance means something breaks and we fix it. So this is more a collection of examples of things that get broken and how to fix it. And in this case, this manual contains a lot of images, and the procedures to fix the different parts, the different example is developed using images, and the steps come along with many photos. And so using the move around digital tool was more complex because it's more complex to add pictures there. So that's why we in this case we only developed the guided tool. So this is again the table of contents for the handbook regarding corrective maintenance. The wind turbine taxonomy has been kept, and again we have the same parts, but now we have different examples of like I said, things breaking and how to fix it. And we have added the same information for corrective maintenance using the guided digital tool. So if you see this screen looks the same as the screen for preventive maintenance, because we have used the same taxonomy and the same component breakdown. Again, when we click on one component, the first thing that we can find is a short video on how to access that specific component. So for example, for hub and blades, there's a video, a very short video taking the person from the bottom of the wind turbine up to the specific component, in this case, the hub and blades. And then you can find a list of different examples on if you can read repairing the blades general condition, or repairing structural faults, different examples. This is how it looks like, and in this case it shows in steps, so the different steps that you need to perform to repair that specific component. And so you can see once you click in one of the components, you can see how many steps you're going to have to read, and you have the arrows to move. And there are a lot of pictures, and again, to try to engage the student in reading through all these procedures. And again, like before, once you have finished on how to read a corrective procedure, you can either select another task from the same element, or change element, or just finish. If you if you choose select another element, then we go back to the main menu, the first menu that you see when you click on the guided digital tool. And so that would be for the corrective maintenance section. So we can then now move on to the predictive one. Now, this section is organized similarly. So we have first the written material, the handbooks, and then the digital tools. And in this case, we did, again, the guided digital tool option and the move around one, the same like we did for the preventive maintenance section. But now predictive maintenance, it's differently. Here, this section is more theoretical. So we all know that predictive maintenance, it requires a higher qualification or higher more advanced training. So this is what we try to include in the handbook. We included more theoretical explanation, and the handbook is divided in condition monitoring. So condition monitoring of rotating parts, and then health monitoring for structural parts. Then we added a section for electric and electronic components. And finally, we presented some case studies. So this part, the predictive maintenance part, is a bit more complex. So maybe not that appropriate for technicians, but or it depends. It's more specialized, but I'm sure you all know this. Again, we have the guided digital tool, but like I said, the main menu is now different. So now we don't have the 10 elements that we defined the main assemblies for the wind turbine. We now have different sections for theoretical explanation of predictive maintenance. But again, we can see this very nice like kind of presentation, but that it's interactive, and you can easily move from the different parts of these predictive maintenance techniques. And the same for the move around, and you can move around and you will find labels, and you can click on labels and to see what techniques you can perform on each of the components. Finally, or moving on, after we have explained So the main types of maintenance, preventive, corrective, and predictive. We have the offshore section. This it's only including the differences with onshore, which means that here again we can have a handbook. We don't have the applied section because we didn't have these nice pictures that we have been seeing for an offshore wind turbine. So it's only written material, highlighting the special requirements that are, like I was saying, different from onshore to offshore. And we have a specific document for foundations, which is probably the main difference between offshore and onshore wind turbines. Then at the end, we added a module about management and contracts, where we can find examples of different contracts for balance of plant, for O&M, and for offshore O&M. So examples. This is maybe is not that interesting for some students, for technicians, but or maybe it is so that they know more or less how they look like. And then to finish the section, we also have quizzes like the ones that Simon and Donatella presented for section 1, so that the students can test what they have learned. In this case, we have 7 quizzes with 15 questions each. Like Simon and Donatella explained, you can, once you do, you click on one of the tests, you don't have to finish it. You can just mark some questions and it saves. You can go out and then go back and finish it. And every time it asks you if you want to resume or if you want to start again. And so you can develop the test as you like. And then at the very end, we added a section called Broaden Your Knowledge, where we put some general information. This information now, you can see that the PDFs are not secure because these are this is free information that you can find on internet, but it's we find that it's very interesting and it can help in broadening the knowledge for this section. So that's it from my side. And thank you everyone for listening. I don't know if there are any questions.
We have no questions now, but there's a discussion at the end of the webinar. Probably there were some additional questions from attendants. Now it's time for Jaume. Jaume is going to present the life extension, repowering, and health and safety section 3. Jaume, are you there? Jaume? So we see Jaume, but we don't hear Jaume.
Okay.
You're on mute. Oh, no.
Let's see if I can manage the screens that I want to show you. Sorry. Well, I will try to show my presentation or my screen, but
You're in section 4 now. Eh?
Yes. Can you see my screen?
Share screen, yes, with some green seeds, a cactus.
Okay. Let's see.
Yeah.
Sorry, but I cannot see what are you saying?
We can see
Now this module.
Sorry?
We can see the Moodle, the web page.
Okay. Well, let me start what we have done inside the project. First of all, we participate in the module 1, producing a software called CADWEX that tries to explain the concept of cascading damage. The cascading damage is not exactly the failure tree of a machine. The failure tree is focused on the probability of having a failure. Instead, the cascading damage concept is focused on how the failures evolve in a machine along the time, going from one failure to the next failure, and making the things go worse every time. How it works? Well, the CADWEX has the software, and then two videos explaining how to install and to use the software, and another video with an example of how using the software. Also, we have a document explaining the same, and for explaining a little bit how it works, the software, starting from the information provided by the experts. Sorry. Oh. Well, the experts what do is to, I will try to show you in the video. No, here. Oops. Oh, no, it's not possible. Okay, the experts what do is to explain us how a failure has a previous failure that is the cause of the present failure or damage, and there are several damages that are the subsequent damages that will to the present damage will evolve a long time. Okay, this kind of relationships of previous damage, present damage, and subsequent damage is what we call a triplet of damages. And what do the experts is to establish all the known triplets in our machine, okay? And then by the means of comparison of the different triplets, we take one triplet that contains the damage we are interested to see how it evolves a long time. For example, the first triplet, and tries to establish which will be the subsequent damage of the subsequent damage of that triplet. If we have these four triplets, you can see that the triplets A, B, C can be compared with all the triplets, but in the third triplet, the present damage is the previous damage, the subsequent damage is the present damage, and we can establish that if we have the damage A and as a previous damage, a present damage that is the damage B, and a subsequent damage that is C, one of the chains we can establish is that follows with the damage G. Okay, we can see here when we compare the elements of the triplets, we can establish that the change will follow as that we have say A, B, C, and G. If we repeat that comparison with another triplet, we can make a longer chain of damage and see how the damage will evolve. Okay. Well, this is what Windext do from the information provided by the teacher, by the experts. I will try. No, we cannot enter in the as we are in the conference. We cannot access Moodle now. Well, also the software shows information of each kind of each damage and how to detect it, how to repair if we have the information, how to detect it and to repair. Okay, and sometimes the cost of detection and reparation. Well, this is about CADWEX. Now we will talk about Module 4. Of Module 3, the section 3 is about repowering life extension and end of life. And this is the section that gives name to the project. Windext is a project about extension of life of the wind farms. Okay, this section is divided in 4 modules. One is about taking the decision of the extension of life. And the second is on the recent challenges from the health and safety point of view of the life extension. The Module 3, repowering and end of life. And the section 4 is the end of life cycle of the wind farm. Each module is composed by videos and learning documents. Okay, so here the videos are interactive videos. We have here an example. The interactive. Oh, look, no. There is a problem accessing to the network during the conference. Well, the videos have been designed with some teachers and educational experts to try to find the best composition of the interactive area of the video. And at the end, we decided to have an area for the presentation, then an area for the teacher explaining of the lessons, and an area I will try. Okay, and an area for the interaction of the student. The videos show information on the lesson, but also the student, by clicking on these buttons that appear during the explanation, can access more in-depth information about the lesson. There are three kinds of buttons. One is a button that brings to a document. The other is a button that brings to another video. And the third is a button that brings to a tool or to a web page that has some interactions. Okay. For example, we can go there. And also we can see some information inserted in the videos. Sorry, but as the network is fully dedicated to the webinar, we cannot access now to the Windext platform. Okay. Then we also have, we also have the documents. The documents are documents that are PDFs, protected, and allow the student to have more knowledge about the lesson, and well, explain things that due the limited time of the lessons in video format that we have tried to maintain below the 15 minutes cannot be explained inside the lesson, the video lesson. And well, of course, we will have the same problem. We cannot navigate through the PDF because the limitations of the network, but no, we can do it. Okay. And for example, in health and safety, we have several lessons on the risks of the recycling of e-waste, electronic waste, or the blades or other components, and about how to perform the operations of dismantling a wind turbine. Well, there are several lessons on that. Oh, here, for example, this in recycling electronic waste. Well, we can see the buttons, or for example, for blade component recycling, we have the information of main components, which is the function, or sorry, let's go. The risks of each of the components. Okay. And for example, in another module of the course, we are in techniques for blade recycling. In that module, we try to show more innovative approaches for recycling the blades. For example, we introduce the plastic digestion, or the gasification of the components, that are techniques that are being investigated now, and can bring a new way of recycling blades in that case, and well, are quite impressive on how they work. And then finally, we have been working also on the module of SimulWind. SimulWind, as you know, perhaps you know, is a project that was developed years ago, also inside Erasmus+. And what we have done is to maintain the software. SimulWind is a simulator for virtual reality. And what we have done is to adapt to could be played or execute not only with the Googles that were primary foreseen to be played, but we have added 3 new Googles that makes more easy for the training centers to execute the software. Also, well, here we have the software we can download here. Then we have the instructions on how to install the software, and finally we have developed the guides for using the software. And what we have done is to develop 2 different 2 different 2 different guides, one for the students, another as a real project. Here we have the guide. This is the student procedure, and this one is, oh, sorry. Well, I have been wrong. I will try now. We cannot download now. Well, this is a real-like procedure, but it has been modified to allow the student to know how to perform the practice inside the simulator. And we have the instructions of the real procedure, but we have added more precise instructions for the student to be able to run the software. Because we have detected that the students sometimes, the students sometimes find difficult to know how to work inside the simulator. We think that this is very helpful, and in the test we have performed in the pilot tests, the students and the teachers were very satisfied of having that kind of helps. Well, this is all. If you have any questions, we can talk later with in the questions turn. Okay.
Okay. Well, thank you. There is also a quiz in the section 3. There are also some questions to follow what you have learned in that section. And this, the SimulWind is in fact is in section 4. Is going now to be. We are going to enter now in the presentation for the digital tools from WEXIM, from David Gonzalez from Tesignor. We have received some questions about the difficulties of using the server. We will explain at the end of the webinar, because I think we hope that it's a transitorial situation. the server in UCI had a cyber attack. There are now some restrictions to get access to the Moodle, but we'll explain how to proceed now in this period. We hope it will be short, but we'll explain. But at the end, when all of this will be fixed, you can get access to Moodle from any kind of computer. And so now it's time for David. David Ruexim, are you there, David?
Yeah, I'm here. Good morning.
Good morning.
I'm going to share the screen. Can you confirm you are seeing my screen? Yeah. Okay. Hi. Good morning.
Full screen. Full screen, David.
Sorry, I'm going to try to. Okay. Okay. So I start. Yeah. Start. Alberto, can I start?
Yes.
Yeah. Okay. So we have developed the training in virtual reality, the WEXIM module that is contains different experiences. We are going to see now. There is a tutorial in order to know how to interact with the virtual reality and all different experience like the disassemble the gear motor, elevator emergency, high speed safe blocking, self fuse, torque wrench, 360 degrees tour, and a quiz. First, the tutorial, the student learn how to operate the different elements of the simulator, like how to move around, access the help menu, and pick up elements. We have here a small video with different exercises that we can test in the tutorial. We can grab objects, move around the experience, put on the PPA. Yeah, move around. Okay. So disassemble the gear motor. In this practice, the student proceeds to unmount one of the gear motor with different operations must be performed during the practice. So this is a experience with a high difficulty and it lasts around 30 minutes, the complete experience. Here is a small video of different part of the experience, like using the spray and move around the turbine. You can see the information that appears in a tablet in the left hand. For each step, you can see the information and the help on what's the next step. And you can move around the simulator. So it's important to use the proper tools. In this case, you have to mark the So I don't know if you can hear the sound, but for each of the steps, there are natural sounds that the student can hear with the goggles. Well, this is only a part of this this experience that, as I said, it lasts around 30 minutes. This is only 1 or 2 minutes of the experience example. Okay. The next experience is the elevator emergency. The student learned how to use a Goyan lift and how to make an emergency descent in the event of a power failure using the emergency brakes. This is the difficulty of this experience is easy, and it only lasts 3 minutes. So we have a short video. In this case, we have to operate the elevator. We have to access it using the controls. We have to use the PPEs to be safe. And when the event appears, you have to use the brakes to download from the elevator. As the same with the other experiences, we have real sounds, but we can hear now the sounds, but it's very realistic. Okay, the next experience is the high-speed shaft blocking. This is it has a medium difficulty, and the total experience is like 20 minutes. And in this experience, we access the wind turbine completely stop it. So also we have here a short video of half and 1 minute. As in all the experiences are similar in the use of the interface for getting help and the use of the different tools to remove, in this case, parts of the screws, and also how to you can move around the experience. Also, we have had help to show the student where they had to put in this case the wrench in order to make it easier to know what is the next step they had to do in the experience. Okay. The next experience is the self-use. The student learn how to perform a fuse replacement maneuver in a high voltage switchgear using the 5 golden rules of problem with electricity. It has a easy difficulty, and it lasts also 4 minutes. So here we have the information of the 5 golden rules. We can interact with the self-use. It appears information in the self-use in order to know what's the next steps. Also, you have to use the PPEs to verify the absence of tension or voltage. Okay. So the next experience is the torque wrench. In this exercises, the student will learn how to perform a work tightening operation. It's a high difficulty experience, and it lasts between 10 and 30 minutes because there are different exercises inside the experience. And as the same in as the other experiences, we have the information on how to make the procedure. The next experience is the 360 degrees tour. In this experience, the student can tour a real wind turbine. It's made with 360 degrees photos, so you can navigate around the turbine and see a real generator. Yeah. Here, different information that the student can open in order to know the different parts of the generator, and they also can go to different parts of the wind turbine. The different hot spots in order to interact with the experience. Okay. And the last experience is the quiz. This quiz contains technical questions about all simulator experience. There are different kind of questions like selection of the right answer. There are other questions that you have to localize different items in these 360 degrees photos. We can measure the total time that the student is working in the quiz, and each of the question, the time using in each of the questions. And also this is possible to select only a number of questions in an aleatory way, in order to not repeat the question from one student to another. Okay. So the how to install the websim on the goggles on the Oculus Quest 2. now we are working in publish the WebSim application in the Oculus Store. I hope it's going to be enabled as soon as possible, but now Oculus is validating the application. So in the meanwhile, it's necessary to install the simulator manually in the goggles. So the requirements in order to install the application is to have an Oculus Quest 2, a PC or Mac, and a mobile with Oculus app installed. The first step is enable the developer account in the Oculus Quest. We have a document in the Moodle where this is all this information. So the user had to access the portal of Oculus developer and activate the organization and enable the developer account. And also there is necessary a validation of this account that can be done by sending an SMC or associating an account to a payment method. The next step is to activate the developer mode in the Oculus Quest 2. That is, it can be done with the mobile application of the Oculus installed in the phone. And we have here the steps. We have to access the device and activate the developer mode and restart the goggles. Once the goggles is are enabled with the developer mode, appears a new menu in the system that is called develop, that appears in the goggles itself. And then we have to install manually the AP key that is the application in the goggles. In order to do this step, we have to install the ADV drivers in the PC or Mac or in the Linux computer, and install these drivers, connect the goggles with the USB cable, and send the application. Sending the AP key via ADV from PC to USB is you only have to execute this command that is also documented in the Moodle, and with these steps we will have installed the application in the goggles. And then in the last step is launch the application in the goggles. For this step, we have to enter the unknown origins application option and select the application. Anyway, this is a temporal installation because we are going to publish the simulator, the WebSim simulator, in the Oculus Store. So it's going to be you will can install the application directly in the Googles without to make all these steps. So this is a workaround in the meanwhile. And thank you.
Okay, thank you, David. We are entering to the last presentation. We have a last session for questions. We have not too many, but then at the end we will clarify how to use Moodle now before to resolve all the problems with the server. Now, Elena Tilko from SGS, you have the floor for you.
Okay, thank you. Can you see my screen or?
Yeah.
Yes. Okay, perfect. I'm gonna put it in bigger. So now you see it good, no? Okay, so let me know. Yeah, sorry. So first, yeah, good morning to everyone. And yeah, the aim of this presentation is mainly to talk about the possible risk inside the European projects, and mainly what we have done to try to control the risk inside the Windext project. So for this, we are going to do like a short brief of the particularities of a European project, just like passing briefly. So one of the particularities is that there is a multiplicity of the stakeholders, meaning that there is the European Commission, the different partners, and other different stakeholders that are taking part. No? This can cause also like some difficulties. Also, another one is that the main client is the European Commission, and it can be different ones, but this is what usually happens, no? And also like one of our difficulties, or what we consider is that the project is distributed, meaning that there is different organization, objectives, the cultures, the countries, so this also makes things a bit more difficult, and the fixed budgets. So there is also a need for the detailed justification of all these budgets that are created for the European project. And another factor is the highly competitive calls and the overemphasis on the early planning of the project, no, because we have to develop the proposal in advance. So this can be another factor. Then I'm going to explain a bit more these factors, and you will understand better. Then the shared responsibility, but because the main role of the project is the coordinator of the project, but you share with the rest of the consortia. So this can also have some problems sometimes. And there is also the multiplicity of the external rules, because there is a restrictive contract, but we don't have internal rules on how to deal with the consortia that we have. In the case we are a coordinator, no? And then also a big factor, no, an important factor here, I think, is the reporting that we need to do in the European projects, and the operation scheme that it can cause possible temporary malfunctions in the different reviews that we have with the European Commission. And also there is like little room for exploratory high risk of research and development. Let me see if I can pass to the next one. 1 second. Oh, no. Yeah, so in any project, so as the project management is always similar, no? But here there are some small differences, but we always have to identify the stakeholders that are involved in the project, knowing the different needs, and related to these needs, to the characteristics of these needs, the different variables and factors of the project. And then to be able to solve these trade-offs that exist in the time in an optimal way, no? So we manage to have a successful project. And here, as in every project, is divided in different phases, but each phase here is defined in terms of the expected results that we have, and they have to be always related to the milestones, to achieve these milestones. This is a requirement when we develop the European project, no? So what are the main management areas here? We have selected the scope of a project, the time, the cost, the quality of the project, the human resources that are involved here, the communication, the risk, the external requirement, and the integration of the whole of these points. Here I'm gonna go just to some of them where I consider it can be more risk in a European project, no? The project scope is one of them, because it has to be defined during the proposal phase. So this means that you need to do it in an early stage, and then it's in a fixed contract, so then it can be modified, but sometimes it's a bit difficult, no? So the risk of the project scope is the overambition, because we need to create quantifiable targets, and because if we do it in an early stage, can have some difficulties, and also like the risk of artificial adaptation to the European Commission priorities. So this is can be partially or not be, but it can happen, and the difficulty in identifying the real need of the client. Usually when we have to write the proposal, no, sometimes there is still some research to do to be sure that we can identify to and involves these stakeholders and identify the real needs of the project. And then the problems of the limits to change the scope because of the restricted contract. And also the reductions that can be possible when we get a red flag from the European Commission in the review or in the final phase. This also doesn't induce to changes in the scope, no. And also, of course, in all the factors, the multiplicity of stakeholders it can be always a bit of creating some troubles. Then in relation with the time is similar. It always affects that as we need to create the proposal and define the time at the beginning of during the proposal, there is always a generic definition, no? And the estimation that sometimes we do for these multi-annual products that we want to create, this can have some abstraction because of the generic that we can create, and this can create also like some big risk, no? And the coordinator or the person who is writing this usually is organizing the timeline in an unilaterally way. So this means that at the end, this always affects to the project development, no? Because it's difficult to estimate the real time that we need, and then to do the changes is difficult in a European project. In relation with the cost, we know just like the resource about availability and the capacity is just known as a partner level, and the budget allocation between partners is always a sensitive issue that is happening between the partners and the different tasks that they have to do, no? And always because there is a strict cost categories, and the resource management is the responsibility of each partner. The contract funding is always fixed, and the deviations is difficult because we have this restricted contract, no? So we just can have like some possible corrections, but it's not an easy thing to do, no? And of course, they need to justify with the strict parameters that are imposed by the European Commission. In terms of the quality, the quality management of the project, it can have also some difficulties because there is a problem of non-existence or variety of the quality policies that can be in the different organizations. So we are talking that we take part, no, in different countries or in Europe. So this is always creates a difficult coordination, and the fact that the perception of the benefit of the quality in a distributed environment is limited. And the quality we usually is more applied to the products that we develop during the project, no? So not to the process of how the project is being developed. As we know, the different phases of the quality is the quality planning. Here we can identify the quality standards in order to avoid this or to mitigate the risk that can happen, no? The quality control, monitoring the specific results and establish the quality standards, or in the quality assurance for systematic activity of confirming compliance with established quality standards. In relation with human resources, I also consider this part a bit important because the partners' internal hierarchies and the management lines are often unknown for the rest of the partnerships, and the variations are also unpredictable. No, I think if for everyone who has participated, no, in European projects, there is always variations of the resources and the human resources that are taking part in the different projects, and this can also affect, no, how the project is, the progress of the project. So the allocation of the contracting of resources is always left to each partner, and this can also create some troubles, and the assignments of the roles and the responsibilities, we need to do it also during the the early stage of the project proposal, and it's only done also like at the organizational level. And yeah, the development of the project team is usually also limited to the usual representatives. In this respect, it is more important to bear in mind that variations in this can undermine the efforts made. And the last factor I have decided to add here is the communication. And I think this area is important because it's the distributed implementation environment involving the different types of organization, cultures, language is difficult to manage because it exists at different levels. So we have the European Commission, the coordination, the different partners, the groups that we have for different tasks, or the partners that we involve in the different parts, and the different stakeholders that are also involved during results or deliverables that we want to create, and in general the communication that we have with them. Of course, also we have to follow the requirements of the European Commission that are not always easy, and the geographical distance always can have some limitation. Of course, now we have different tools and everything is much more easy, but it's not the same as having the person in front of you. And at project level, the responsibility for closing lies usually in the coordinators. And here, in the last point here, is the risk, and this can be developed as an explicit activity, and the implementation of the certain mitigation or plans can be sometimes problematic because they should be incorporated into the contract, but it's not always easy to estimate the probability or impact of some of the risk. And so there's no provision for budgetary reserves is envisaged. So the different phases that we have included here is the risk identification and assessment. That is the identification and assessment of different risks and opportunities, and the process that we have to address them. And then the risk chain control, that is triggering, identifying, and analyzing and managing changes in risk and different opportunities. So as we have said, so here we have the identifying, analyze, the action, the monitor, and the control. No, that are the main things we need to have to control and to mitigate the possible risks. In this case, so here we have created a project risk analysis, which means the identification of the potential risk and obstacles that can happen during the development of a project, and also during the future exploitation of the results. As we say here, the exploitation of results is also an important thing in the European project. So, and justifying also that you have done this exploitation of results. How we carry out the project risk analysis? So we carry out in two phases: the quality phase, which has two main areas, which is the technical issues. This is the feasibility of the project task and risks related to the timing, the appropriateness, and the feasibility of these results, and then the risks that are related to the partnership, which means the intellectual property rights, the lack of ownership, and the conflict resolution, etc. How we rank these risks? So they are ranking according to the probability to happen, no? From 1 to 5. And the probability, so on the different impact, no? To measure the impact is also from 1 to 5. And the product of these two figures will represent the risk value of that they have in the project, no? And then it can from 1 to 25, and this can be classified as remote risk, low risk, medium, and high. So in the quantitative phase, they are mainly related to the non-fulfillment of the planned budget due to the lack of involvement of the partners or to the inadequacy of the initial planned task. Here, the combination of both risks can affect to the initially approved budget following the following matrix. A situation that must be avoided in the first place because of the implications on the expected income of the partners, but also to avoid also possible conflicts that can arise between them. So here, for example, how can it affect to the final report score? If we get at least 40% and below 50, we can have a 25% of reduction. If we have at least 30% and below 40, we have a 35% of reduction. At least 20% and below 30, we will have a 55% of reduction and so on. But below 20, we will have a 75 reduction. So you see, it can be a really important thing to be able to deal with the different risks and solve them in advance. So what is our aim of the corrective actions? So as we say, to reduce the likelihood of the event to happen, and to mitigate its effects, to the risk to occur. So in order to carry out the identification of the risk of this project, so we created at the beginning of the project the matrix risk assessment. So we created this first matrix at the kickoff meeting, and then we have reviewed in some of the transnational meetings to be able to know to be able to be ready if a critical event occurs. This matrix risk assessment includes corrective measures for the identified risk according to the value of the risk. So here you can see more or less how we have created the table. That is there is one side with the probability, as we say, not likely of the event to happen, likely, and so on, and then classified in the impact: minimum, minor, moderate, significant, and severe. So putting these both indicators together, we can get what is the risk level, to measure what is the risk level of the identified risk, which can be remote, low, medium, and high. So here are some examples of how we have done this for the Windext project. We decided to divide this risk for them in the different work packets because we thought that it will be easier to identify the specific risk. So it can be, for example, in the working package 1, so the lack of communication, how we can deal with this. So organizing mostly virtual meetings, promoting the involvement of all partners, so creating project management tools. I don't know, so another options can be like, here we have the difficult to meet the timeline. So here in this case, so we can have to try to establish a clear calendar and effective control tools. So in general, you can see that here we have done different risks that we have detected, and then we have shared to the different partners in order to see if they can identify some of them that we couldn't identify. In the case, for example, of the working package 2, it was also like how to deal with the lack of involvement of experts and stakeholders, or the lack of interest of the direct beneficiaries. So how can we deal with that? Which options we have now to try to mitigate this risk, or how to actively involve the direct beneficiaries in the design phase, or highlight the practical aspects to the training material. So, but this involves to control the project and be active during all these phases to be able to adapt the risk to the reality of the project. So I'm not going to stop in all the risks. So it's just in order to get a more clear idea of what are we doing in to identify the risk. So there are some that are more clear, that is like, for example, that the contents are not good enough. So how we can define the contract, the contents of the modules, and define the information. We need always a fluent communication among partners to involve the support and advice from experts, etc. And also here in relation with the organization of the pilot test or the evaluation of the project, we can include measures to control the evaluation of the results, or also for the dissemination and exploitation, to disseminate of the projects and to be sure that we have created an innovative project, and to increase the dissemination channels, and of course involve all the partners and so on. So I think with this you can have an idea of what we have done to control the risk of this project, and this is a big part in order to be able that we manage to have a successful projects and to get the results that the Commission was expecting. And with this, I think I am done with my presentation. So I don't know if you have any questions.
Thanks, Elena. There's any questions? I think it has been very useful to have a control of the quality of the project in all of these 3 years since the beginning of the project in 2020. We suffered the problems with the pandemic, but finally it has been we have kept many meetings to follow the progress of the different work packages. Now it's time for questions. We have not many questions now. But one thing is important to clarify is Marius. What is the situation of the server? We have received some questions.
Yes. I saw the questions. There seems to be an issue today with accessing the platform. Unfortunately, 3 weeks ago we had a cyber attack in our university, and the technical support team switched off all the servers and services. And so the Windext is hosted in a university server, and now they are switching everything back on, but some things might experience issues for a few days. This is out of our control, unfortunately. It is a central authority of the university that controls it. They might still be running some checks, and that is why we have some issues with access. We expect that everything will be resolved soon. If we cannot access it right now, you can either try from 4G connection or some other Wi-Fi, or try again in few hours. As I can see during the webinar, some people has access to the platform and made new accounts. So this is a situation, unfortunately, about that, and we are hope so to fix it as soon as possible.
So we have okay. So about questions. Well, thank you, Marius.
You're welcome.
So try again using a connection, Wi-Fi. No, Wi-Fi is not the best option. No, so we need to be connected through using cable. Not that
4G. He said that the connection should be with 4G. 4G,
so using data. Using the data, but only if you have a portable computer. You have no. It is going to be complex. So using 4G is easier than to use Wi-Fi, because Wi-Fi you are going to find some problems. But I will hope that this resolve in the next days. And please disseminate the platform, and because our intention is to be used all around Europe or the world. We have already done in the project. Sasha, there is no question. I don't know. You want to add something? You want to say some comments about your role as a disseminator or communicator? Make some remarks, Sasha. Sasha's on mute. I don't know. Oh, no, it's open now. Sasha? Sasha, you want to add something? No. Okay. Thank you, all of the participants. Thank you to the partners. I think it has been a very interesting experience. We hope to repeat it in the near future. And we hope also that the project has been going to be useful for the maintenance community. And also, as I mentioned at the beginning of the session, of the webinar, the goal it was to train people, because now the market is demanding a lot of people, and there is a lack of workers. So we hope to, thanks to Windext and also some additional projects around Europe, we are going to be able to have good professionals in the near future, because the market is very demanding, and the transition is not only political transition, depend not only to carry out projects, but depend also how the projects are being maintained. So thank you very much. Thank you, our partners. Thank you, all the participants. I will see you soon. Bye.
Thank you.
Bye. Thank you very much.